Hi, welcome back. In this video we're going to look at rational expressions and equations of rational expressions. And what we'll do is we'll go through the definition, talk about how to simplify them, we'll do an example, and then in future videos we'll look at combining rational expressions, and then we'll get to actually solving equations involving rational expressions. So let's look at the definition of rational expression. So a rational expression is an expression that can be written as the ratio of p over q, where p and q are polynomials. So basically a rational expression is just a polynomial over another polynomial. Now we call a rational expression reduced if the two polynomials have no common factors other than 1. Having p over q in reduced form is going to be an important part of simplification, which is what we tend to want to do when we have a rational expression. We get it down to its simplest terms. To simplify a rational expression, what we'll want to do is take the polynomials p and q and factor them. Once we have them factored, we'll want to note the values of the denominator that would make it 0. When we have a factor denominator, that's very easy. Any value that can be plugged in to make a factor 0 would make the entire denominator 0. Those values must be excluded. Once we have those written down, we can go ahead and cancel them, so to speak. We can divide out the common factors. Okay, let's take a look at this example. Here we're just asked to simplify this rational expression, and we can see that it is indeed a rational expression. We have a polynomial in the numerator, x to the 4th minus x to the 3rd. That's a 4th degree polynomial. In the denominator, we have x squared minus 3x plus 2, also a polynomial. This one is a quadratic. All right. So we'd like to simplify this, and to simplify, we're going to factor p and q. So let's start with the numerator. We've got two terms, and the first thing we like to do when we factor is to look for any common factors between the two. X to the 4th and x to the 3rd both have a common factor of x to the 3rd. This would be x to the 3rd times x, and that's just x to the 3rd times 1. All right, so we can write that as x to the 3rd times x minus 1. And we can always multiply back through to check to make sure we factored correctly. X to the 3rd times x is x to the 4th. X to the 3rd times negative 1 is negative x to the 3rd. Great. Okay. Now that goes over the denominator. We want to factor that as well. Now this is a quadratic, and we can use the techniques that we know of to factor a quadratic. I think we're going to try to factor this. Let's see, no choices for the x squared here, just 1 and 1, so x and x. And then we need pairs of factors of positive 2 that add up to negative 3. So negative 1 and negative 2 are going to be the right choices. And again, we can always multiply out to check. So let's do that. X times x is x squared. Okay. X times negative 2 is negative 2x. Negative 1 times x is minus x, so that's minus 2x minus x is minus 3x. And then minus 1 times minus 2 is plus 2. All right. Now at this point we can note what values would make the denominator 0. So here we can see if we plug in x equals 1, we're going to get a 0 in the denominator, and a 2 also would make the denominator 0. These values have to be excluded regardless of how this ends up being simplified. So I'm going to just go ahead and add that. X cannot be 1. X cannot be 2. All right. Now that we've taken care of that, we can simplify this. Notice there's a common factor in the numerator and denominator. X minus 1 and x minus 1. All right. These can be divided out. we could write this as x minus 1 over x minus 1, and those cancel to be 1. So I'm just going to go ahead and do that. And we can do that because we have products everywhere. And we are indeed dividing out this x minus 1. Okay, the result leaves us with an x cubed in the numerator. X cubed times this would divide out to be 1, so x cubed times 1, divided by, and then again 1 times x minus 2, so just x minus 2. All right, and then we include the domain restriction, x cannot be 1, x cannot be 2. All right, now this is simplified because the x cubed and the x minus 2 have no common factors other than 1. Right, and then we could then, whatever this was a part of, we can then use that, this factored expression along with the restriction on the domain, essentially the values of x that can be plugged in. All right, in the next video, we'll look at some more simplifications involving combinations of rational expressions.